Hi everyone, this is our lecture 2 in the DSCS 703. In this lecture, I will give you a brief overview about the Python programming language and its basic constructs and structures. First of all, Python was developed back in the 1980s and early 1990s. However, it just became popular during the last decade or so due to its popularity in machine learning, data science, and artificial intelligence. If you look for Python right now, you will find two versions of Python, Python 2.x and Python 3.x. Python 2.x is as of January 2020, it's dead, it's not supported anymore. The current version of Python is Python 3 and it's the only supported version, and the current version you can download from python.org is 3.8.3. So Python 2 and 3 are somehow completely two different languages. Sometimes they differ in the syntax, sometimes in the semantics. That's why we asked you in the previous lecture to stick with Python 3 and to make sure that you download Python 3 or 3.8 at least. Python is interpreted language, scripting language, interpreted language, very high level programming language. And it supports a multitude of programming paradigms such as object-oriented, functional programming, procedural programming, logic programming, etc. And it is supported with a comprehensive set of standard libraries. These libraries that are often open source and available on the internet cover a wide range of domains such as numeric modules, such as crypto, OS networking, GUI, and much more. So what's the philosophy of Python? Python was designed around the idea of getting or developing or designing a programming language that is beautiful, that is explicit, that is simple, that is code more readable, and much more. You can read about the Zen of Python programming language from its website at python.org dev peps. And you follow this link and you will get more about the philosophy of Python language. So, however, having said that, what are the major features or the notable features of Python? Python, first of all, Python is easy to learn. Not only for those who know programmers, not only for those who are familiar with computer programs and have a background in computer science, it's almost easy to learn by everybody. And it supports a quick development and rapid prototyping. It also cross-platform. This is very important because when you write a program in Python, you do not need to care about the platform, I mean the OS. You write the program on Windows, you move it to Linux or to Mac, it behaves the same. It's also open source. This is one of the points that give Python one of its strengths. So it's open source. So there are a tremendous amount of a tremendous number of developers all around the world who contribute to the Python and to its development. So this is makes the development in Python fast and rapid and cover a wide range of application. This is contributes to its applicability for a variety of applications because it's in a constant development. So also it's extensible and embeddable. What does this mean? It means that you or anyone in the world can write modules in C or C++ and extend the Python interpreter with these modules or embed these modules inside the Python code. So it's highly extensible. And it's also, as I said, supported by a large and active community. So when we start learning Python, the first thing we need to start learning is the typing. Typing in Python is dynamic. What does this mean? Python is a dynamic programming language. A dynamic programming language, this means it have a dynamic type checking, dynamic type inferencing. So programmers who write Python code does not need to care much about the variable, the type of the variable. They only need to know about just the name of the variable and the value that they need to put in that variable, because behind the scene the runtime system, the Python runtime system, checks these values and define, infer their types and create the proper variable with the proper type behind the scene for these variables. So there are variables and there are types for these variables, but the programmer often does not need to care about these types. Having said that, Python is a dynamic programming language and there is types behind the scene. So what are these types? These types can be divided into subcategories. What are these subcategories? We can divide them into different domains. The first domain is the numeric types. Numeric types have subtypes inside of them, integer, float, and complex. We are not going to talk much about complex. We will stick with integer and float. And float, these are real numbers that we know in other programming languages in the form of float, double, float or double. Integer, sometimes we have them integer long or long int, something like this. So these two data types cover the numeric types, integer, float, and they have constructs for them int and float respectively. You can find more about the data types in Python from this website, which is at python.org /3/library/std types.html. You can find the numeric types and other types. But to get sense about some sense about this numeric types, let's say that we started the Python interpreter from our shell in the interactive mode. We will get this prompt. We can use this prompt as a calculator, so we can like say enter 3 plus 2 and it will give us the result. We can use the modulus. We can use the function, the built-in functions such as APS, which represents the absolute value. Whenever we give it a negative value, we will get the positive of that value. We can use the construct float. We can convert any integer to a float, or vice versa, convert any float into an integer. This gives us the 5. Even if it was like 5.9999, it will get and produce to us the 5 as a result, because it will truncate whatever after the decimal point. Also, there is a construct for the complex numbers, and we can use the exponentiation or the exponent or the power. 2 to the power 8, for example, gives us 256. So that was about the numeric types. The second category, or the second domain of types covers the sequence types or sequence data types. We have plenty of those, but in this lecture we will cover 3 of them, which is strings, list, and tuples. We know strings. Strings are available in C++, Java, C#, other programming languages, and we know that these strings are enclosed in in double quotations. So these are a sequence of characters, surrounded by double quotations. In Python also we can surround it by double quotation or single quotation, as we will see later. Also we have lists, just like arrays in other programming languages, but in other programming languages arrays often have to be homogeneous, which means the same data type. But in Python they can have even heterogeneous data and values inside of them. The third type is tuples, which is almost similar to records in Pascal or struct in C. These are list of values. We can express them as a comma separated list of items. We will talk more about them and see them in an example. So for example, let's say we started the Python shell in the interactive mode, and we defined a variable. Let's say our variable in here x equal 5. This defines a variable named x with integer type and the value 5. This here defines a new variable also named y, type float, because the value here looks float. It has a decimal point, this means it's float, and puts 6.9 inside y. This here creates a variable named s, and look here we have a single quotation. Single quotations or double quotations means the same in Python. They both represent a string. So this s is a string and has ABC inside of it. So we can check the type of each one of these variables using the type built-in function. So this is a built-in function. You give it the variable or the value, and it will give you the type of this variable. Sometimes when we write our programs, we need to understand, or we need to make sure that it is of a certain type. So we use this built-in type function. Notice that we can, when we give it the variable x, it gave us class int. This means int is short for integer, and the main point here is class. Class means everything in Python is an object, and every variable is a reference to that object, even for simple variables such as integer, float, or strings. When we gave it, when we call type with the y, we got a float, class float. When we call the type function for the s variable here, we got the str, class str, short for string. Also, the other type here, which is list, we can create list by using the square brackets. This is one of the ways to create a list, and initialize in this way. We initialize it with three values, three integer values, 1, 2, and 3. If we check the type of this variable L, we will get the class list. Also, for tuples, as I said before, tuples are sequence of values separated by commas. So in this case, I have t as a tuple because I gave it a list of comma-separated items, 1, 2, 3. This will create for me a tuple and save its address, its reference in t. And when you check the type of t, you will get the type tuple, class tuple. So we can also print the value of L or the value of T by just like the print statement, or if we are using the active shell, we just type the name of these variables. So in this case, when I type the T or print T, I got these values, and notice the banana parentheses or the round parentheses. Lists are surrounded by square brackets. Tuples are surrounded by round brackets. This is how we can distinguish when we print their values. Distinguish between list and tuples, I mean. When we talk about strings, here, as I said before, strings are created by enclosing the characters by single quotation or double quotation. If we start the string using the double quotations, we need to end it and close it by the double quotation. If we started with a single quotation, we need to close it by the single quotation too. However, one important thing to notice about a string is that strings are immutable. What does that mean? What does this immutable mean? Immutable means that we cannot change the value of the string or any character of these strings after we create them. So after I have the variable myString here assigned with this value, I cannot come to this myString and change maybe the comma here or the I or any part of it. Of course, I can create a new string from this existing string, but I cannot modify it. This means immutable. You can find about many strings available in the Python library and by following this link in here. And check these functions that will allow you to assist you to manipulate and check strings. Also, most of the other programming languages, strings have escape sequences. So \t means setup, \n means a new line, \r means carriage return, and so on. So, but sometimes we have we need to disable the escape sequences. In order to do this, we can have the R before the string. Literal, this will give us a raw value, raw string, and disable these escape sequences and their meaning. You can also find about them in the link that I gave to you. But to understand these strings and what I mean by raw strings and versus normal strings, or traditional strings, let's say that we have a program named ex.py, and this program has only 3 print statements. First of all, it prints hello, and there is a \t and a \n. By the way, print by itself, whenever you have a print, there is a new line by the end of this print by default. When we have \n here inside the string that is going to be printed by the function print, we will have 2, one from this \n, one from the print. So when we see the execution by running this script, this Python script or this Python file or program using the Python interpreter and hit enter, we will get first from this statement, we will get this. Notice that hello is, there is a space in here. This is the \t in here, the tab, and it depends on your machine on how this tab is defined, whether it's 6 spaces or 4 spaces or whatever. And there's a new line in here from the print, and also there's a new line from this one. So this line will be empty. So there's nothing will be printed in here. The second print statement in here is from this. And notice that we have R before the string. Notice that the R is before the double quotation or the single quotation. This means this R disables the meaning of \t and \n and gives you a raw string. And when you print it with the \t and \n without parsing, without understanding their meaning, because R tells the execution or the runtime system do not look inside the string, just print the string as is. Don't interpret or parse anything inside that string. Also notice that there is a print has one string and space and another string. This is space and this is another string because we have 4 double quotation. This is closing this one and this closing it, this one. In Python, when you have 2 strings next to each other separated by a space, it's by default a concatenation. What does this mean? It means that you almost having the same string, the first string concatenated to the second string, and the output will be Python is so cool, just like what we have in here. So 2 string literals beside each other are automatically concatenated. The second data type is list. When we talk about lists are unlike strings, are immutable, which means we can change them, we can modify them anytime. Also, lists are nestable. What does this mean? We can have a list inside another list, inside another list, inside another list, as much as we can, as much as we want actually, and this what we have 2-dimensional arrays in other programming languages, or 3 dimensions, or undimensional array. So nestable feature of list, the nestable feature of list allows us to create multi-dimensional arrays. In this sense, we can create lists using the construct list or using the square brackets containing 0 or more elements. In this example here, I created a list called mylist, and notice that I use the square brackets, not the round brackets. Round brackets are used for tuple, as I said before. And notice that I have integer in here, I have apple in here. This is a string, right? Single quotation, but a string. Single quotations in other programming languages is used for character, but in Python, it's important to mention that in Python we do not have a character data type. We have only string, even if it has only one or single character. We have a sentence or string with spaces inside. No, doesn't make any difference. We have another number here, so this is this statement creates for me a list called mylist, a variable, an object, and it has 1, 2, 3, 4. It has 4 elements. These elements are indexed from 0, 1, 2, and 3. So the indexing of these elements are 0, 1, 2, and 3. So if you want to print this list, you do not need to have a loop. In other programming languages, okay, I need to, for example, in C or in C++, I need to have a for loop or a while loop or do while loop, whatever, to print the elements of this list. I can, in Python, print the list by just calling the function print and give it the object that I need. So this will print me or the output of this statement will be this. This is the output. So it will print the list as I can see it in here. Also, I can change any value of this list, or can delete any value, or can extend or add to this list more values. So let's say I want to modify the value at position 2, this one, which means green apple, to banana. I can do this. I cannot do this for strings, but I can do this for list. I cannot do this, as we will see, for tuple, but I can do it for list, because list is the only changeable type out of the 3, I mean strings and tuples and lists. So if I print the list right now, I will get this. Notice that after this modification, green apple was changed to banana. I can replace maybe this number with another list. Notice this list contains another 2 lists. This is the first list, this is the second list. This is a two-dimensional array, 2 by 2 array, you can say. I can have it in replacing this number. So if I want to print the list right now, I will get this. Notice that this number was replaced by this two-dimensional array. It's now almost three-dimensional array, but not for all the elements, or only the element at position 3. So I can use the dot operator with the list, and I can have dot, and I have many functions. One of them is pop, just like stack. It will remove the last element, and if I give the result to print, it will print me the item at position 3. So right now this one is removed, this one is removed, and now the list has only 3 elements, 0, 1, and 2. So what is important about sequence types is that you can access them with a negative index. Negative index start from right to left, and start from -1, -2, and so on. Positive indexing start from left to right, and start at 0, 1, 2, and so on. So my list sub -1 will print me the last element of the list. Actually, the last element is not at position 3. The last element is the one at location 2, or -1 right now, because this one was deleted. So the index, but that was green apple, but right now when we changed it to banana, so it will print me banana in here. And of course I can create list with any time during the program, and I may use the list comprehension, as we will see in the future. This is one of the forms for list comprehensions. This means, okay, give me the x times 2 for all x in the range 0 to 5. We will study this later on. And I can print it, and it will give me this list. So as we said, we have 3 major types. The str, which is a string, it's immutable. We have the list, which is mutable, and we have the tuple, which is immutable. Maybe we didn't talk much about the tuple, but we will cover them with others more in the future. But if we want to see an example, we can have my list have spam, eggs, and toast. This statement creates a list with 3 items. This is item 0, this is item 1, this is item 2. It has 3 items, so I can work with this list. I can check whether eggs in my list or not. This will give me true, because eggs is in the list. So this is, will check. The n operator here is very important. It will check the value on the left of the n inside the object or the structure in the right hand side of the n operator. Also, I can use the function len. Len right now is 3, because yeah, the last element is indexed by 2, but the number of elements are 3, so it will give me 3. I can create a new list. Let's say my new list has coffee and tea. This is a new list, and I can concatenate 2 lists, not only 2 strings. Use the plus operator to concatenate 2 strings. This is 2 lists. This will build 2 lists for me, and the result will be my list, spam, eggs, and toast, and then add it to it my new list. Of course, I didn't save it. If I need to keep this list for later use, I may say L equal my list plus my new list. I can create also tuple using the construct of the tuple. I can give it any list. Let's say this list, new list, I can give it to a tuple. Now I will convert convert my new list, which has two elements inside of it, coffee and tea. I convert it to a tuple because I gave it to the construct of the tuple. This is my tuple right now, and if I print it, I will get the round parentheses or the round brackets in here, not the square brackets that represent the string, the list. I can also use the index to find out the index of any of these values inside any of the sequence data types, whether it's tuple, whether it's list, whether it's string. So if I want to find the index, I can say, okay, my tuple dot index of t, which is in this case 1, because this is, or in this case 1, this is 0, and this is 1, so it will give you 1. I can create another list just like this, my long list, and I may use the subscript in this way. The subscript in this way, it's different from the one we saw before, which is which wasn't contain the colon in here. This means from position 2 to position 4. From position 2, this is position 0, this is position 1, this is position 2 included in here, this is position 3, this is position 4. The slices in here give me the sublist that start at position 2 and ends at position 4. So 4 would not be included, so this will give me this sublist. And note that it's a list, not anything else, because it's surrounded by square brackets. Common sequence operations, you can use the n, you can use the not, the negation of n, not n, you can use the plus, the star to multiply the sequence data type, whether it's tuple, whether it's list, whether it's a string, by n times, or in this form also. You can subscript like this, or like this. Note that we have k in here, another column k, which means the step. This means if this is positive, this means I has to be less than j, because I plus k until we get to the j. We can use the len, we can use the built-in function min to find the minimum value, the smallest item in S. We can find the max of S, largest item in S. We can use the index, we can use the count index to find the index of the first occurrence of X inside S. The count of X, the number of occurrences of X inside S. These are very important functions to practice and to use, and they come in handy when you develop your program. This is contribute to the Pythonic way of programming and developing your Pythonic algorithm and Pythonic program. There is also for mutable data types and mutable sequences type, you can modify the set. Actually, this doesn't work for the string and does not work for the tuple and does not work for the string. It only works for the list. This works for the list only. You can modify one of the elements in the list. You can modify sub elements on the in the list. You can del. This is an operator also, actually, just like n. You delete subset of the list S. You can replace t. Have t to be to replace the sublist represented by this slice, which is from I to j with step k. You can delete these items. You can append and add x to the end of s. Actually, as in this case, it's a list. You can also extend. Extend means adding the contents of one object into another object, or count the number of occurrences of x, or index, or insert, or at position, at specific position, pop to remove the last item, remove an element. For example, pop, you can replace it by 3 statements. having the value, deleting the value, and returning that value. Reverse, you can reverse any one of the elements inside the list. You can sort the contents of the list, and we'll come to this because it's sometimes the require when it has complex data or heterogeneous data, you need or structure, you need to define a lambda expression or a lambda function. We saw strings, sets, strings, list, and tuples. We also have one more important data structure, which is set. Set, just like sets in math, they contain a collection of unique objects. We have two of them. One is is called set, and the other is called the frozen set. The only difference between them is the frozen set is immutable. You cannot modify. Set you can modify. You can add to elements to it, and you can remove elements or delete elements from it. But for frozen set you cannot. So let's say we have a basket that contains apple, orange, apple. Let's say, notice that apple is repeated here, and it's fine to have repeated items in the list or in the strings, but when it comes to the set, we talked about unique objects, so it will not be multiple items will not show more than once. Pear and orange. Notice also orange are repeated. So this is at position 0, this is at position 1, 2, 3, and 4. This is a list. Why? Because we know it's surrounded by square brackets. So this is a list. We can create a set, out of this basket. This means we need to drop the repetition for any item. So if we create fruit using the construct of the set and give it the basket, so it will give, okay, apple, orange, apple already found, so don't have this one. Pear, okay, orange already have, so the size of the set will be 3, and it will contain, and if you print it, it will be represented using curly brackets, not square brackets, not round brackets. These are curly brackets. And orange, pear, and apple. The order here is not important, because you know the set order is not important, and repetition is not allowed. There is no repetition inside sets. You can also use the n operator that we saw before. Let's say we want to check whether any item inside a set or not. You can use the n operator. In this case, it will give you a true. You can, if it's not there, it will give you false. For example, this is the result of this expression is false. You can have a string and convert it to a set, not only a list. In this case, it will take every character in this string and put it in a set. Sometimes we have this is A, this is also A, this is also A, this is also A, this is also A. I can use this construct to find the number of characters that are unique inside this statement or inside this string. This will create a set and save it inside A. This is also create a set and save it inside another variable called B, and will dump all the repetition. For example, I will have only one A, one L, one C, and A, it's already there, Z and M. So you can, what's important about this is that these sets, you can perform the union, the intersection, the difference between these sets, just as you are using the union between two sets in math. So if I want to print the A, I will get, okay, the unique characters inside A. If I wanna find the difference between A and B, the letters that are in A but not in B, I can use the minus notation here. Will give me this new set. I can use the vertical bar here to represent the letters in A or B, which means the union or both. So this is the union of both of the sets A and B, and I can have the intersection, which is letters that are in both A and B. The intersection between them is A and C. In this, I can also find the letters that are in A or B, but not in both, not in both, just like the complement of this one. So sets are handy and useful, and you need to contribute use the set, use the list, use the string, use the tuple when you are thinking about the designing of your algorithm in Python. This contributes to the Pythonic way of programming. One more data structure, which is dictionary. Dict or dictionary, it's almost like a hash table or a map in Java, or an associated array in which there is one array and associated with another array, but here we have them in one great data type, one great data structure called dict. You can create it using this dict function. So let's say that I have a grade book, and the grade book is a dictionary. Right now this creates me an empty dictionary. I may add a dictionary, an element to the dictionary, and the element in the dictionary consists of two parts, a key and a value. This is between the square brackets, look like a list. We have the square bracket, the subscript, but the subscript here is a string. So this is the key, and this is the value. This is our value. This will add a new entry into this empty dictionary, Susan student, and the value is, the key is Susan student, and the value is 87. So whenever I have this string, I will get this value associated with it. So if I print out the grade book, I will get one element inside this dictionary, and the dictionary consists of key, colon, and value, and one item. If I have more than one item, I will get comma in here, and then the key, colon, value, comma, key, colon, value, and so on. But in this case, I have only one pair of values. Of course, I can add more whenever I want. Let's say I want to add to the grade book the grade for Peter, and it's 94. If I have a huge or a large or a big enough dictionary, and I need to find the list of keys, I can use the name of the dictionary dot function keys. I call the function keys on the grade book that I want, and it will give me a list. Notice a list with all the keys inside the dictionary. If I need the values, I have also another function called values. I can have a list with the values. If I want to add also more in the future to the grade book, I can add for Tina 99.9. And if I print the book, I will get, okay, this is Peter, this is the first item, this is the second item, and this is the third item. So the size, the length of this dictionary is 3 because it contains 3 items. The first item is associate the key Peter to the value 94, Susan student key as a key to the 87 as a value, Tina as a key to the value 99.9. And I can also change the value whenever I want. Let's say I want to add more grades to Tina. I may add and list. Yes, that doesn't. This is actually possible and valid in Python. When it comes to Tina, I have the key Tina, and the value is a list. This is okay. This is the value, and the value for Susan is an integer. This is or a float, because we have the same point. This is a float, but sometimes I can add list or another dictionary or another tuple or another string or whatever I want. So dictionary are very important and very usable to them designing algorithms and providing good solution in Python. You need to start thinking how to use them, utilize them in your algorithm. So we talked about the Python data types. We talked about numeric types, integer and float, strings, tuples, sets, and list, and also dictionary. Maybe I need to update my slides. The dictionary also. Now it's time to talk about control flow, because this is not good enough to create a useful program. In order to create a useful program, we need to have a control flow. And when we talk about control, we need to talk about if statements, loops, and conditional statements and loops. So the control flow tools in Python, first of all, the loops. And in Python, we have two loops. The first one is the while loop, and the other one is the for loop, which we will come to later. Loops start with a logical expression followed by a colon and then set of statements. Look here, statements. This statement needs to be indented and in the same amount of spaces. So you need to get them aligned together on the same amount of spaces or tabs. Okay, so to perform a block. So let's say that I have a loop. Let's say that I have I equal 1, and then while I less than 4, I is 1, yeah, true, 1 is less than 4, print I, it will print for me 1, then increment the number I, look, print, and I are aligned together inside the same block, because this alignment for the statements inside the block perform the block and form the block. When it comes to flag equal true, this is not inside the while loop. How do I know that? Because it starts, it's aligned with the while loop, not aligned with the first statement inside the while loop. So it's aligned with the while keyword itself. So this is outside the loop. So I will keep doing the loop and performing the statements and executing the statement inside the loop until this condition becomes false. And since that I increase the value of I by 1, so then I'll print 2, then 3, because 3 less than 4, then I becomes 4, for the not less than 4, false, I will come to flag true, while flag true, and this is the logical expression, and I less than 8, okay, true, and I less than 8, so I is 4, I came with I 1, but inside the loop it was changed to 4, and because it was 4, I exited the while, so I get to this point, and in this point I get inside the loop. There is a colon here, and there was a colon also up there for that while loop. Print flag, which is in this case true, and the value of I, which is 4, increment the I 5, 6, 7. When it comes to the 8 is not less than 8, so true and false, false, so it will get you out of the loop. So I printed 1, 2, 3 in here, 4, 5, 4. Yeah, it was here, but yeah, it was here. 4, 5, 6, and 7 here. And when it got to the point 8, I exit the loop. Since this is the last statement in here, and there is no more. There are no more statements to be executed. This means the end of our program. This is a program, actually. This is a simple program in Python. The second part of the control flow is the if, the conditional statement. The if expression, then statement followed by colon. We may extend the or have a program just like this. If any value that's not 0 other than 0, it's true, because a is 1, it will be a is true, so it will print a is true here in here, because there is no else. This is if not b, b0, not b, not 0, value other than 0. So the 0 is false, not false is true. It will print b is false. So we got this printed from here. And if a and b, a is true, b is 0, false. So this one will not be printed. If a or b, or any one of them should be true. So a is true. So a or b is true. We got this printed from here. So this was not printed. This is the if statement. We can have if else also, if expression, else expression, and if we have more than if chain if of statements, we don't have else if, we have the elif in here. So let's say if I have a greater than b, a is 1, b is 0. If a greater than b, yes. If a greater than c, no. Else print c is greatest. We don't, since this was true, we will not check the elif in here, and we will not come to this to this part. So we will get the output only c is greatest, not from this one, it's from this one. Okay, why is that? Because a is 1, b is 0. If a greater than b, yes, a greater than b, 1 is greater than 0. Then we enter this block. Since we have successfully entered this block, we will not come to the elif part in here, and for sure we will not come to the else in here. Now we check a against c. So a is not greater than c, so we come to the else part in here, and we print out the c is greatest, or is the greatest. Okay. So now we come to the second and the last type of for. It's the loop. It's the for loop. For loop is our for loop have this format: for variable in sequence. And you remember the sequence data types? This applies for the sequence. You can go over a list or a string or a tuple, and you can perform for each element or each item in that sequence. You can perform a set of statements in here. So for example, if you have a string like this in here, let's say for letter, so letter first will become A, then will become E, then will become I, then will become O, and finally will become U, and for each one of them it will print vowel letter in one line. So from the first iteration in this loop we got A, E, I, O, U. So from this loop we got all of these printed. Then for I in this list 1, 2, 3, so we printed I. And there is another function called range. When I have the items, it will give me an iterable, similar to a list, but not a list, not actually a list. If you check the type for range, it will not be a list. From 0 to 3, it will give you 0, 1, 2, 0, 1, and 2. It will not give me 3 because up to the 2, 3. So that's why I printed 0, 1, 2. This is from here, and this is from here. Okay. These are the control flow. This is the range that I talked about before. It gives you an iterable function, and you can have it from 2 or from 2 with the step that we talked about in the sequence. It was k, in the tables before, from 2 and maybe negative step, because this one bigger, the from is bigger than the 2. So 20, 18, 2018 and 16. Look, from this is from here, it 0 to 2 with the step 2, it's 0, then 2, this one, this one from this from here, okay, 0 to 4 and 6. It will not give you the 8 in here. It will not give you the to the point of oh yeah, it will not give you the 14 in here. We can give us the 16 but not the 14. 0 4 0 1. This is the k is missing, so it's by default 1, by default positive 1, so it's 0 1 2 3. These are from here. So when it comes to the control flow, like other programming languages, we have the break and continue. We can break any condition, any loop, or use it inside the if statement, or continue the loop, the rest of the loop, and go to the condition. We have in Python also we have pass, because we do not have the empty body, the parentheses to indicate the begin and the end of that body. So if the body is empty, we will have the pass for it. And we have else also for the loops in here. Not only for the if else statement, we can have the else for the for and for the while also, for the loops I mean. And the else for the loop, we get to the else part whenever we get the condition of the loop false. Whenever the condition of the loop is false, we get to the else part. But if we got out of the loop using break, or for any reason, exit or whatever, we will not get to the else part. So we may use the continue or the break in the way that we like. Right. Okay. So right now we have the tools, the control flow tools and the data type that can allow us to create a simple Python program. So in order to do this, let's have the exercise, and in this exercise let's talk about the Fibonacci sequence, or the Fibonacci series. We know the Fibonacci series start by 1 and 2, and every term after that is the sum of the previous 2 terms. So we start by 1, 2, and then the third term is the sum of these 2 gets to here. So it's a 3. When it comes to 5, it's the sum of these 2. When it comes to 8, it's the sum of these 2, and so on. So let's say that we want to print out the first 10 terms of this Fibonacci series. The first 10 terms are here. What if our problem is to print out all the even terms, even valued terms that are less than formula? If we want to do that, we can do that. We have the loops, we have the data structure, we can print them out, we can sum them out, and here I am asking you to sum, to find their sum and print them out. So first of all, I need to accumulate their total. So the total, I have the variable total equal 0. I have the first term and the second term, f1 and f2, and notice that I have double assignments in here. This is double assignment. I have, this is you may never saw this before in any other programming language. This will evaluate the right hand side and then comes to the assignment. So the first term in here goes to f1, the 2 here goes to f2, so it's almost like saying f1 equal 1 and f2 equal 2. It's exactly this. Then I created an empty list to find these even valued terms that are less than 4 million. Then I need a loop. Okay, so while f1, which is 1 right now, less than 4 million, if f1, the remainder of dividing f1 over 2 equals 0, this means f1 is even, then add it to the total here and append it to the list. I need to find the sum of all those even values of the Fibonacci series that are less than 4 million, and I need to identify them, so I keep accumulating the total and appending these values to the list. And when I need to update f1 to become f2 and f2 to become the new f1, so I do this assignment. It's very interesting. It's very Pythonic in this way. This is in other programming languages. You need 3 statements, 3 lines of code to do this. In Python, we do it only in one line. So f1, f2 equal f2 comma f1 plus f2. As I said before, we evaluate the right hand side first, so we will get f2 and we will get f1 plus f2. We have them as a tuple, then we assign these values. So the result here, let's say the result here is r. We assign f2 to f1, so we move f1, and r here we assign it to f2. This will make the solution consistent. Then we keep going until we have an f1 that is equal or greater than 4 million, because we always keep updating the value of f1. And as I said before, the right hand side is fully evaluated before setting the values, before the assignment I mean. So we do this. By the end of this loop, when this condition gets false, we print the total and we print the list and we print the count, which is the len of list. So the total is this, and the items are these items. From all of the items, all of the terms that are less than 4 million in the Fibonacci series, we have only 11 of them are even. I may ask you the question in the later on the homework about this, to modify the program, maybe find the primes or find the odd or whatever. Okay, what about functions? Before we end our lecture today, let's talk about functions. Functions are very important and very useful, because sometimes there is a piece of code that I need to call multiple times. I do not need to repeat that code every time I need to call it. So I put it inside a function and I give it a name, and from that name I use that name to call that piece of code whenever I want. To define a function, there is a keyword called def. Maybe this is one of the places in which you declare things in Python. The function name, the argument list, colon, just like any other block, in the for, in the if, in the else, in the while, and set of statements indented, all aligned together inside the body or the block of the function, just like this. We have 2 statements, hello and how are you. Today, these are 2 statements. These are aligned, set on the same distance from the beginning of the body of the function, so they align together in the same way. If this is one program, it comes the execution from the top. This is a comment. This is not executable. Means that we already have a function, but we do not execute the function until we call it. So this is an empty line. Here I call it. When I call it, I jump into here, execute the body in here. This is the beginning of the body, right? Print hello, print how are you today, and return none, nothing. By default, return none. there is a non data type in Python, and it will print you this. So this is allows you to define a function. The basic parts of the function, the keyword def, the function name, list of arguments, which is none in here, a colon, and body. And the body might be pass, empty body, as we said before, the pass keyword. And every function in Python retains something, even when this return is not here. So this function returns none. So if you add a print to this statement, you will get none. Okay. So none, it will be after here, in this place. So another function, you may have like other variables, like name, some list. By the way, all variables are passed by reference, because everything is a reference. If this object is mutable, is variable, I can change. If I changed it inside the function, it will be seen outside the function. Okay, so if you have notice here that this function retains two values, so the one will be assigned to A and the two will be assigned to B, and I give it my name and my list. This is the first parameter will go here, and this is the second parameter will go here. Execute the function and return. Okay, and the result will be just like this. In here I have names, which is a mutable object, variable object that you can modify. So I pass it to the function. Inside this function, you will get names. You have a for loop that will print hello and Susan, hello Peter, hello William, whatever the end, then modify the values at position 0, at position 1, at position 2, instead of Susan, Susie, Pete, and Will. When you come back out of the function and return back here and print the names here, you will find the new values. Even though this names is a list defined outside of the function, but since I passed it by reference, because everything is passed by reference, any modification inside here, it will be reflected outside of the function, and when I print, this is the result of the final print statement here. So if you come to the Fibonacci exercise that we saw before, and you need to modify it to make use of the function, we can do that very easily. And in here we need to learn about the underscore. This is underscore to underscore, but like they look like one giant underscore in my slides. So these two underscores surrounded name, this is a global name. Whenever you run the program as the main module in your program, it will be assigned main. But if you have it in a separate module, you need to do nothing. You only need to import that module, and this name would not be the same. So this will allow you, we will cover this later on when we talk about delivering and distributing modules. But having this will allow us to import this function from anywhere or to run it as a standalone program. That's what I mean by underscore name equal main. So this is a modification to the previous program, the Fibonacci series that finds the sum of all elements that are less than 4 million. In here, finds their total, find their count, put them inside the list, and return the total, the count, the list, and print them, and it will print us everything that retained from here as a tuple actually. So one more thing to learn before we end is the input. Sometimes you need to ask the user for something to enter. For example, I may need to ask you about your name. What is your name? So input will ask the user for a string. Whatever it's entered by the user, it will be received as a string, and then in here I printed out whatever the user entered. So this is shown from this message, and then I typed test input, and then print will take test input and will print it out. If there is nothing in here, this will not show here, so this is will consider a prompt. If I typed an expression like this, it will not be evaluated. 2 plus 2 times 5, it will give me 2 plus 2 times 5 as a string, because it will not understand this is an arithmetic expression or this is a string. It takes a string as a string and print it out. If you need to evaluate the expression, and you know this is a mathematical expression, you may call the function eval, and eval will allows you to evaluate this expression unless it has a problem inside. So this time we will get 2 times 5, which is 10, plus 2, which is 12. So this is the input function. It's very useful, it's very handy. It's input and along with the print, they are used for input output. So if we come to the part in which we redefine the solution of the exercise presented before with the function and with the input function, we may ask the user to enter the limit instead of having the limit fixed or hardware for 4 million. We can ask the user for the limit and then convert this limit into integer, because as we said before, the input returns a string in here, and the string needs to be converted into integer before I can use it in a conditional statement. So I give this integer value to n, and in here, instead of having 4 million, I have n, and then I will find the total and find all the Fibonacci even valued Fibonacci terms that are less than n. So this is an improvement. If I entered 4 million, I will get this. Notice that this function returns total and L. So this is the total, the first part of the tuple. This is the second part of the tuple, which is a list. Okay, so this is almost the end. We notice that we are using a style in here, the indentation, the amount of indentation that we talk about in here. This is a block inside. This is another block, which is the third sub-block inside. So there is a syntax that we need to follow in Python, and there is a convention that we need to follow in order for other people who read our code to understand it. So it's very important to go and study the guide that will guide you how to develop your Python code in a highly readable way. There's also a tool called PyLint. You can download it and use it to make sure that your source code maintain a good coding standards. So it's one of the valuable tools that can be used. If you go to this link, you will install it. It's actually a Python module, but you need to learn how to use it. Later on, I may explain to you or give you an assignment about it. So this is here we come to the end of our lecture today, our second lecture. We introduced the Python data types, we introduced the Python control flow structure, we used the material in here comes from different locations, but most of them belongs to the docspython.org that I talked about before. So it's good to visit this website and read about these from the Python source code, because it's one of the most useful references available to us during this semester and for those who program in Python. Thank you so much for listening today. Enjoy your week, and goodbye.